Hey guys, welcome to yet another session by Great Learning. So, guys, in this live session, we will be going through Docker Swarm step by step. That's our topic. Now, guys, I want a confirmation from your side. I will look at the comment section, the chat, and if you guys, I'll check confirm if you guys can see my screen and if you guys can hear me properly. All right, so while you're doing that, there's going to be a little bit of a lag. So while you guys doing that, I'm going to go ahead and show you guys something. So here, guys, Great Learning Academy, what we have come up with is basically we have come up with something called Great Learning Academy. So I know a lot of you out there who are freshers or people who are looking for jobs right now, and you might have find it difficult to find jobs without those particular skills that you might need. So this is the perfect opportunity for you. Just go to your browser, type in Great Learning Academy or greatlearning.in/academy if you guys want to go directly, and check out all the various courses that we are providing. So basically what we do here at Great Learning Academy is that we provide people free courses, and these free courses will basically give you free certifications. So just go ahead and try any of these courses out, like Python for machine learning foundations, introduction to R data visualization, cloud foundations, or introduction to digital marketing. So we have a lot of different courses out there. You can even check out different domains, and these are completely free, and this is an initiative that we have started for a lot of those people who can't afford those expensive courses out there but still need to do it to get better jobs and upskill themselves, right? Or make a better career for themselves. All right, now we will go ahead and continue with our session. But before that, guys, also please make sure to subscribe to our channel and hit the bell icon so that you don't miss out any of our future updates. Now, we have a lot of different live sessions that we do daily. We have a lot of live sessions that we do on coding, on digital marketing, on data science, machine learning, AI. So if you're interested for any of those domains, please subscribe and stay updated. All right, so let's look at all the different topics we'll be covering in Docker Swarm step by step. So first, I will be giving you guys a brief overview of Docker itself. Then we'll talk about the Docker objects. So this is for those people, who don't really know about Docker and still want to get into the whole session. And for those who already know, just tune in when I start talking about why orchestration, or just keep on watching. And if you're watching this as a video, you can just skip to why orchestration, and from there onwards, I'm basically talking about Docker Swarm and all of its components. Right? So let's immediately get started. What is Docker? So Docker is a tool. In software development, we have a lot of different things that help us to make the software, and Docker is one of those tools. So what Docker basically does is that it basically helps in developing, building, deploying, and executing software in isolation. It does this by creating containers that help us completely wrap up software. What do I mean by completely wrap up software? Now, let's take an example. If you wanted to shift from one house to another house, right? You would do that in boxes because you have a lot of items in your house, and you would keep them in your boxes, and you would shift from your house to the other house by keeping all those items in that box. Similarly, in a software development process, you might need to shift your software code from one system onto another system. Now, this may be a requirement for different reasons. A good example would be, developer writing his code and sending it to a tester, and tester testing his code. So in that case, they also have to make user boxes. These boxes provide a good layer of isolation and protection from the outside environment. Now, the code may run on the developer's system, but it may not run on the tester's system. To avoid this kind of compatibility issues, we make use of something called containers. These containers basically take everything that is necessary to execute a code. It takes environment, that it can be the operating system, and it takes the dependencies that are required to run the code, maybe their libraries or functions, and they take the code itself. They take all these things together and put them in one container so that this container can be shifted from one system to another, and be very independent across the different systems. So the isolation provided by these containers provide a layer of security to these containers. Other than just the compatibility, they also provide a layer of security. So this is what Docker does. It helps us to create these containers and help us to develop code inside of it, build that code inside of it, deploy the whole software using these containers. So this is what Docker is. It's a tool that helps us in software development. So what is a container? Let me go in a little bit more detail. So containers are software that wrap up all parts of the code and all of its dependencies into a single deployable unit that can be used on different systems and servers. So you have your code, you have your libraries, you have your environment, and all of them are put in one container. And inside of this container, you can go ahead and use this environment to execute the code and the libraries. It's like a VM, if you wanted a better analogy. But it's not as big as a VM. Just think of it as a very light scale VM that can be used in multiple different systems, independent of those systems. So you have multiple isolated containers that can be launched together from microservices, which can be easily managed using any orchestration tool. So if you guys already know what containers are, and if you already know what Docker is, you know that you can create multiple containers at the same time. And these containers generally are managed in a certain way. And they're managed by using tools like Docker Swarm or Kubernetes, right? So these kind of tools are being used to manage these multiple containers, because you have to, you have to handle all of those containers you have created. Why do we even, launch or deploy these software on containers? Because it's easy to manage them. That's why we make use of containers, because we can easily manage any software that we have easily. And we can do that using tools like Docker Swarm that this video is particularly about, and tools like Kubernetes that are used in the the industry very like a lot of people do make use of Kubernetes. It's very popular. All right, so why do we need containers? So again, consistent development environments, it provides you a great layer of isolation, and then microservices. So microservices architecture is a way of, basically handling a software and deploying that software. So that's what microservices is. So these are the two main reasons why you may need containers. All right, so let's talk about the Docker environment. So if anyone already knows about what Docker is, then this is just a brief up for you guys, a good revision. So Docker environment consists of these five things and even many more, but these are the major parts, like Docker engine that is responsible for, basically running the day-to-day activities of Docker. Then Docker objects, that these objects are created by the engine and they're used to perform all the certain, things that are required in software development. Then you have Docker registry, which is used to store images, and Docker compose, that is, basically used for creating multiple containers, and Docker Swarm, which is basically, managing those different containers. All right, so we have objects like images. Now, Docker images are a set of instructions that are used to create containers and execute code inside of it. So they're basically like blueprints for those containers. So a user will go ahead and create a blueprint, and this blueprint will be used to create containers. Now, this blueprint can be for anything. You can even have a Linux environment configured inside of this blueprint, and then when you do create that container will be created with the Linux operating system inside of it. So these are basically your images. Think of them as blueprints. Then you have volumes that are Docker objects. So Docker volumes are basically persistent storage locations for containers. They can be easily and safely attached and removed from different containers. So they're basically like, hard drives. You have containers, right? And those containers they don't have permanent storage themselves. They have temporary storage. So if you want to store data permanently, you make use of these volumes. So these volumes act like hard drives that store the data for the containers. So if you wish to remove a container, you don't have to remove the storage with it. You just remove the container and you detach basically the hard drive or the volume. Now these volumes can be, safely removed from one container and attached to several other containers. And that's why they're very useful. Then comes, basically networks. So networks are important in Docker, especially so because, Docker networks basically connect all the different containers. So if you have, 3 containers and you want to connect them, you make use of a Docker network. One of the more powerful things about Docker containers is that they can be easily connected to one another and even other software. This makes it very easy to isolate and manage those containers. So when I say isolate, creating a network around a set of Docker containers basically creates an isolation layer. Nobody can talk to these set of Docker containers unless specified so. Now you can have, multiple sets of Docker containers that are connected to each other using, specific network drivers. Like these 2 sets of Docker containers might be connected using bridge networks, and all of them together might be connected using an overlay network. So you can see how it creates a layer of isolation, and you can manage these different containers using network, overlay network and all the different networks drivers you have. All right, so let's talk about Docker Compose. So for now, let's just understand Docker Compose is a service within Docker that helps us launch multiple containers at the same time. Right, so normally when you're running Docker containers, right, you use one single command in the Docker CLI and you run one container at a time. You can't keep on doing this if you have to launch a service that has 10 containers. And if you want to test continuously, then you might have to remove those containers and launch them again and again and again. So you can't keep on using that one line. And this makes it much easier to basically launch multiple containers. And in deployment time, this is especially useful. So people use Docker Compose for that purpose. Now, why orchestration at all? Now, guys, before I continue this, give me 2 seconds. Let me just go grab a cup of water so that I don't remain parched for the rest of this live session. All right, guys, I hope I didn't make you wait too long. Yeah, I have my cup of nice cold glass of water next to me. Now let's continue with the session. Now, I explained to you a lot of Docker concepts so far, right? So these concepts are going to help us understand orchestration, and they are the tools that we will implement while working with orchestration. That's why I explained them to you. Now let's start by asking the question, why orchestration in the first place? So orchestration basically allows us to manage and maintain multiple containers. This is especially helpful in software development where we may be making use of microservices architecture as it breaks down the software into small manageable chunks. Having different configurations and environments becomes easier with orchestration. So let's take the definition of orchestration itself. Where have you heard orchestration before? You might have heard of music operas, and you have orchestrators over there, right, who orchestrate the music. So in a similar manner, you have orchestrators, tools like Docker Swarm and Kubernetes. They basically manage the containers. So if those containers were musicians, you would have an orchestrator managing them. And similarly, you have Docker Swarm tools like Docker Swarm and Kubernetes tools that are orchestrators that orchestrate these containers. They manage these containers. They make sure that they stay up, they manage the health, and they make sure that different configurations, if needed, are passed on to these containers, etc., etc. So that's what orchestration is. They allow us to manage and maintain multiple containers at the same time. And this is especially helpful in software development because you have microservices, you have sets of containers acting as one single software. So if you want to figure out any issues with that software, you have multiple containers, so you know where to pinpoint. So it becomes much easier. You can easily scale and descale using orchestration also. So this is why we need orchestration. In short, orchestration helps us better manage our deployed software. So what are the benefits of orchestration? So I've already listed a few. Let's talk about them here more. So we have easy deployment where you can deploy, your software much more easily. You can easily manage these containers. You have easy resource management for these containers. It allows for health monitoring of these containers. When I talk about easy resource management, you have to allocate certain resources for certain features of an application, and to do that you make use of orchestration. Now, you want to make sure that not all parts of your software are receiving the same amount of resources. Now, this kind of discrimination is implemented to make sure that the features that have to be best supported, that are the core of the software, is working fine all the time. That's why you have multiple replicas of those features, and that's why you make sure that those features have the most amount of resources possible. So it's again a battle between how many resources you have and how much they cost to use. So cost effectiveness also plays into this majorly. Then it allows for health monitoring of these containers. So you have multiple containers. Now for some reason one container crashes, maybe for due to some internal issues with the system itself and not with the application. Then you need to know that happened, because these containers are your system. So if one part of it fails, you should know that one part of it failed. Otherwise, how will you correct it? Otherwise, how will you replace it? So that's why health monitoring is important for these containers. Now, load balancing among different containers. So when I discuss load balancing here, when I mean that basically any task for execution is divided among these containers. So let's say you are running 3 services, and these 3 services are basically necessary, integral to the whole deployment purpose of your software. Now you're running them on 3 nodes or 3 infrastructure locations. Now what happens when one of them fails? The the now 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 Sorry, now let's not talk about that. Let's talk about how these 3 services are launched on these 3 infrastructure areas. Now, each of them has their own dedicated infrastructure area. They get mapped 3 to 3. Now, what happens when one of them fails? So, if one of them fails, we have to make sure that the service from the one of them that failed moves on to the other two, uh, given that those other two can handle the new service, the new incoming service. Why the new incoming service? Because the third infrastructure failed, and we have to run the third service somewhere, one place or the other. So that's why load balancing can matter, especially when you have to divide tasks. Load balancing plays into a lot of different, software facets over here, development facets. You can load balance in many different things. It's especially used in task handling, where you divide the task based on what kind of resources are available to you, what kind of servers or instances are available to you, and you divide the task accordingly. Then comes easy updating. When you want to update your whole application with new settings or new features, it becomes easy to do so with the help of orchestration, easy scaling up and rolling back. So depending on the so let's say you have an application and you have a set amount of users coming and accessing that application, but then you see a constant rise, you see a trend of rising number of users. This indicates growth for your company. So you basically start scaling up based on that pattern. But then what happens? Suddenly there's there's a dip in your growth, and you're still making use of those extra servers for running your application so that extra users can access it, but you don't see that many users. So that way you're wasting your resources by having extra servers up, even though they're not required. So in that case, we make use of auto scaling and auto rollbacks, where depending on how many users are coming in and feature prediction analysis, you basically have scaled up. You have scaling up, where you increase the number of nodes or servers that you are using, depending on if there are more users or not. And if there are less users, then you roll them back, right? So this is easy scaling and rolling back. Then it creates a layer of security, obviously. So there are multiple layers when you're talking about orchestration of a particular cluster of nodes or containers, and a layer of security is created over them when you're making use of an orchestrator. So these are the different benefits of orchestration. Okay, so now let's move on to Docker Swarm itself. So Docker Swarm is an orchestration service. So, since it's an orchestration service, all the benefits apply to Docker Swarm that we talked about, any orchestration service. It's an orchestration service within Docker that allows us to manage and handle multiple containers at the same time. It is also a cluster of multiple containers. Okay, so let's remove the Docker Swarm and Swarm separately. So we have a swarm is just any cluster of containers. You have 3 containers and you name them as a cluster. you have three sets of containers and you name them as a specific cluster. To manage this cluster, you will use Docker Swarm. Okay, so inside of a Docker Swarm, you have manager nodes and worker nodes. Manager nodes basically is the manager, and the worker nodes are the ones that perform any task that you have. So this is basically your Docker Swarm. It's just an orchestration tool. All right, so let's see the Docker Swarm architecture. So it gives you guys a better idea. So we have Docker Engine, and the Docker Engine basically helps you create the Docker Swarm. And when it does so, you see that there is a manager node and you have multiple server worker nodes. So these worker nodes are connected to the manager node. So any scaling up, any updation, any health checking happens through basically the manager node. So if you want to update any new features onto these worker nodes, you will do it in the manager node so that the updates go to the worker nodes. So if you have specific tasks, you will use the manager node to divide these tasks among the worker nodes. So let's say you have 3 services. You divide these 3 services using the manager node onto the worker nodes. So your worker node 1 will have service 1, your worker node 2 will have service 2, and your worker node 3 will have service 3. So this is how it works. So I hope you guys understood that Docker Swarm architecture. All right, so and all of it's connected by a layer of networks, overlay network. Docker Swarm components. So let's talk about these different components we have in Docker Swarm. So we have a service, we have tasks, and we have manager and worker. So basically, you guys know what manager and workers do, and you know what a service is. So let me iterate what a service and task is. So task is basically, assigning specific tasks onto workers. And let's move on to service. So service is the main thing over here. So service, okay. So any software is comprised of specific services. You have a web application for a food delivery app. You have multiple services running in that food delivery app. They're just like features. Like features is the same as service in this case, where you have in that food delivery app, you have the tracking of the delivery person. You have the shopping aspect where you're basically going to restaurants and buying things, and you have the payment service, and then you have the warehousing service, that is the whole backend thing. So you have multiple services that together run the software. So that's what a service is. It represents a part of the feature of an application, and you run them on specific workers. So these are the different components of Docker Swarm. All right, so we have studied enough. We've gone through enough theory. Now let's put our hands on Docker Swarm common commands. So this way you guys can learn, with practice what Docker Swarm is, and you learn how to use it. So to do that, I'm going to go ahead and launch a whole infrastructure. So I'm going to make use of something called AWS. I hope you guys already know what AWS is. If you don't know, AWS is basically Amazon Web Services. It basically provides you infrastructure using, as a cloud. So it's infrastructure as a service, and it has many different services also. So the service we are going to make use of in AWS is basically EC2. So here we'll be able to launch multiple basically servers on which we can launch our Docker Swarm. So I'm going to go ahead and click on launch instance over here, launch instance, and we're going to be launching 3 Ubuntu instances. Ubuntu server, select t2.micro. It's the free tier, so you guys can use it for free. I'm going to name the number of instances from 1 to 3. Add storage, no need. Configure security group. So what we're going to do is we're going to make this all traffic and anywhere. So this isn't really safe, but for our practice purposes, this is really convenient because we don't have any networking issues. In later, we'll learn the best security practices and how to create a better networking layer over our Swarm. So let's click on review and launch, and then click on launch. I'm going to choose an existing key pair, live session keys, acknowledge, and launch instances. All right, so we'll view instances and we'll wait for them to launch or get initialized. We just wait for this to turn green, and then we'll name these. Let me just go ahead and name Docker Manager Node. So each container or each node will have a specific purpose. They can either be a manager node or they can be a worker node. So you can have, usually you can have multiple worker nodes and only one manager node. For clarity's sake, I'm going to name this 1. And for clarity's sake, I'm going to name this 2. All right, so we have 3 running instances. Let me go ahead and launch them using my SSH client PuTTY. So I will use this. I'm going to go ahead and copy the IP address from here, paste it, public IP, paste this. Already have all of the other configurations already set. I'm going to open this. Yes. All right. So we have our first instance launch over here. Let's go ahead and install Docker on this. So I'm first going to update this instance. Right. Sudo apt update. This will start updating the instance. Let me take Docker worker node and open this up while that's being updated. For this, I'm going to go ahead and change the color so that it's not the same color. I'm going to make this cyan. I think so, it's cyan. Light blue. All right. I'm going to go ahead and update this also. So by now this must have been updated. Yes, it's been updated. Now we can go ahead and, basically install Docker in it. Now I'm going to use a simple command for, basically installing Docker. That's for practice purpose, using the Ubuntu repositories for installing Docker. All right, so while that's happening, let me do that over here also. Sudo apt install docker.io. Now make sure that if you're installing using the Ubuntu repository in one instance, you do that in other instances also. We don't want any version conflicts, and our project won't run then. Let me get root access so we don't have to keep on typing we don't have to keep on typing sudo. All right, so this is done too. Let me just make sure Docker is installed using docker -version command. All right, so we have Docker installed. So guys, if you want in-depth knowledge about Docker, I have a video on Docker also. You can go ahead and watch Introduction to Docker on Great Learning channel. Right, so there I give you guys a brief, not a brief one, a more comprehensive, knowledge about what Docker is and how can we use it and all the basic commands for it. All right, so we have Docker on each of these instances. Let me quickly do that for the third instance also. For worker node 2, let me copy this. Pink or yellow. Let's make it green so it looks like someone's, All right, so let's try launching this again. All right, so let me quickly go ahead and update this, and we will install Docker on this also. Yep. All right, so while it's doing this, what we can do is we can, basically set up a Docker swarm. So what I want to show you guys is, this is almost done. Let me just Docker version this. Yep. So we have Docker installed. Great. So guys, we have basically set up our Docker cluster. We have Docker manager node and Docker worker node 1 and Docker worker node 2. So our first step is going to be initializing the Docker swarm. To initialize the Docker swarm, you have to go to the Docker manager node. That is the manager node. So our manager node was of the color, this was the color. I hope this is the color. Let me just check the IP. Yeah, it was this one. So our basically our orange one is the manager node, and the green and the cyan ones are the worker nodes. So we'll go back to the orange one. And the command to initialize a Docker swarm is to basically use sudo docker swarm init. So this is to initialize, then advertise address, and then we're going to go ahead and copy the IP address that we want to be the manager node. Then we're going to press enter. All right, so it tells us a few details. So let's go through them. Swarm initialize. So this is the swarm initialize, and the current node is now the manager. So this, the node that we launched it on, is now the manager. Now to add a worker to this swarm, run the following commands. So basically we have created a manager node, and it's the only node inside of the swarm as of right now. To add any more nodes, we have to go ahead and make use of this command. So this command, let's go ahead and copy this. We have copied this, and we'll go to one of the worker nodes and just paste this command. So one more thing we need to do is we need to add sudo over here because we don't have any root access, right? So this is the command. So it will go ahead and join any, basically any workers that you want to join. So I'm going to press enter. And as you can see, it tells us this node is joined the swarm as a worker. Now to check if we have any extra nodes on our Docker swarm, we have to make use of a command called sudo docker node ls. Let me just show this again so you guys can have more clarity. All right, so it's not coming properly because the size for the font is way too way too big. So let me go ahead and change that. So let me change it to 14. All right, so this won't be that clear, but you guys can see it properly. So we have the high ID. Wait one sec. All right, so let me use the command again. Docker node ls. All right, so when I do docker node ls, I can see two nodes over here. We have the first node that is ready and active. So the availability is important because we need to make sure that our nodes are available for accepting tasks and executing those tasks. And we have our second node, which is the node that we are currently on. You can see that from the star over here. So you can see it's active and ready, and it's the leader of the whole pack of the whole swarm. So we have only one node. Let's go ahead and add the third node also. To do that, we have to use this command. So this node also has joined the swarm. So if we come back over here, we do docker node ls again. We can see we have three nodes, all active and ready to accept commands. So guys, we have created our Docker Swarm cluster, and we are managing it using our Docker Swarm commands. So we'll be learning all the basic commands over here. So let me go ahead and show you the first command. That was Docker Swarm initialize. The second was Docker node ls. Now let's go ahead and check out the Docker info command. So Docker info command basically gives you a lot of detail about the manager or the Docker machine you are on right now. So if I press in Docker info, you will see there's a lot of information over here. There's a lot of information. So this information is basically about the whole Docker machine you're running on. So it will tell you the servers, how many containers they're running right now. There are 0 containers in the system. They're running, pause 0, stop 0, because we didn't create any. It'll give you the server version, then storage driver, backing file system, native overlay difference, logging driver, plugins, what are the plugins being used, volume, network, log, and then the swarm. This is the one that we are interested in. So we can see that the swarm is active. So that is good because we want the swarm to be active. This is the node ID. And is this instance the manager? It tells you yes, it is true. This instance is the manager. Then you can see the cluster ID to identify the cluster ID. That is the cluster in which this container is in. How many managers are there? There are one manager and there are 3 nodes. Now this 3 nodes is including the one manager. So you can see the default address pool. So all the addresses that will be given within the cluster to these Docker machines will be like this, 10.00. And something over here. All right. So these, if you want to check any information about your Docker swarm, then you go ahead and use the command docker info. Now we can do the same on other instances also. Let me show you guys docker info over here, and you can see the same same interesting information that we saw in the manager node in our worker nodes also. You can see the node address, manager address is also over here. So it tells you that this node is separate from the manager node, but they're connected. So it tells you what the manager is and everything else you might want to know. So let me go ahead and do that over here also. Right, so we don't have any root access, sudo docker info. Right, so now we can see all of the information on Docker. So there's one more thing I want to show you guys over here. Sudo docker worker token. Fine, I'll just show you guys this later. Alright, so guys, we have basically initialized our Docker swarm. We have added everything we want. We check the node ls command. Now we have everything in our swarm, right? So let's see what happens if one of the, one of the instances wants to leave, one of the nodes wants to leave the swarm. So we have this worker node 1. So let's go ahead and use the command docker swarm. Let me add sudo over here, docker swarm leave. So what this will do is it will basically make sure that this node has left the swarm. So if we do a docker node ls over here, okay, it's still showing active. We'll have to wait a few seconds. It's just so down, right? So the status was ready. Now the status is down. So this means that this particular node is not available for taking any tasks. The status is down right now. It also gives you the status of this. So if one node has left or one node is not working, you will know about it by docker node ls, by seeing it over here. We can go ahead and do that over here also. Docker swarm leave, and will leave the node. Node has left the swarm. Again, it will take a few seconds. It's still showing ready. Still showing ready. Alright, so it's a bit stubborn. It's going to take a few more seconds. Alright, now we can see the status for the others node is also down. So this is how you make, leave your nodes, or you force your nodes to leave a specific cluster. Now, if you want to remove them, there is a command for that also, docker swarm rm and the node ID. I'm going to take this ID and press enter. Just one second, guys. Right, not swarm, node. So this node has now left. If we do go ahead and do that for this also, docker swarm node again, rm. So if we do a docker node ls now, we should not see anything. Oh, nice. So we have all the other nodes removed. So what happens when we want to remove the manager node itself? So let me go ahead and type that, docker swarm leave. It tells us that there is an error. Error responds from the daemon. Daemon is the Docker daemon. It tells you, which does also processing. You are attempting to leave the swarm on a node that is participating as manager. Removing the last manager erases all current state of the swarm. If you want to leave, use the flag force. So we will use the same command, but we're gonna add force, hyphen hyphen force. So this way we have deleted the swarm because node has left the swarm. So if we go ahead and use the same command again, there is this is not this node is not a swarm manager. So we don't have any swarm right now as if to say. So if you want to, basically use create the swarm again, we have to basically create the swarm again. So Docker swarm advertise address. Let me go ahead and copy the IP. All right, so let me go ahead and copy this command. Okay, so we have our Docker swarms again. If I do a Docker node ls again, I can see all my basically my nodes. So guys, these are the basic commands you will need to work with your Docker swarm. So there are more commands. So basically, we'll go ahead and learn how to deploy in a Docker swarm, and we'll basically be managing a Docker swarm, right? So let's go ahead and practice that also. Right, so let me show you guys one more command before we actually move on. Like what happens when you don't have the swarm token. So suppose I cleared the screen and I don't have the swarm token anymore. So, right, so let me just show you that command. Right, so the command for that is docker swarm join token, and for worker, yeah. So you have to type in the command docker swarm join token and then mention whose token do you want. Do you want the manager token or do you want the worker token? So we want the worker and we get the token we have. We get the token we want. You just go ahead and paste this command. So this is how you get the token again if you lose it. I can do that for the manager also. All right. Okay, so to add a manager, just go ahead and use this command. All right, so let's clear the screen and let's move on to the next thing. So the next thing we will talk about is basically creating a service on our swarm. So we have a swarm right now, Docker node ls. Now we want to run a service on this swarm. So basically what we want to do is we want to run a specific container on all of these nodes. To do that, we will go ahead and use the Docker service command. So the Docker service command will create a service for us, and that service is basically the container. So let me go ahead and type in Docker service create replicas. First, let's give this service a name using the name flag. I would say my service. Then replicas, how many replicas are we going to give this? We're going to give this 3 replicas because we have 3 nodes. And we are going to give it a publishing port. We want it to be published on 8080, and we will give it an image to reference. So we want it to reference an Apache server. We want to run Apache server on all of these 3 nodes. So I'm going to use HTTPD, that's the name of the Docker image for Apache server, and then press enter. When I do, it will start preparing that service. Now it's 1 out of 3, 2 out of 3, 3 out of 3 because there are 3 replicas. Now what are replicas over here? So replicas are what the name suggests. They are replicas of the service. If I mention 3 replicas, it will create 3 of those services. But those 3 services will be very, very similar to each other. They'll be exactly the same thing. Now we create replicas to basically increase the availability of a particular service. Now say I have a very important service called the payment service. I want it to stay up all the time. So I create like 6 replicas of it because I want to make sure that if one of those replicas goes down, then I have the rest of the, basically rest of the containers, rest of the services still running. So at least one of those services will be running the feature. So let me just show this to you how it works out. So we have created a service. If you want to see the list of services, we have one service. The name of it's my service. And if you want to see where your service is running, you can type in Docker service PS and then the name or the ID of the service. So we're going to paste the name of our service and then press enter. So when you do that, you can see that there are three containers created: myservice.1, myservice.2, and myservice.3. And each of these services are running on different nodes. You can see the IP of the nodes are different. So this is node, and you can see the IPs are totally different. So to check if they are actually there, or and Docker is not lying to us, we can do a Docker PS. When I do a Docker PS, I will see the list of all the containers there are, and here you can see that we have one container and it uses the HTTP image, and it's myservice.3. So this one is running on our manager node itself. We can go ahead and do that same over here, Docker PS, and I can see a container is running here also. And if I do a Docker PS over here, I can see there's a container running here also. So this is how you basically go ahead and run your containers. So if what happens if I remove any of these containers, let's suppose I do Docker RMF for this service and then press enter. So I've removed this service. So if I do a Docker PS again, there is no service. But if we wait for some time, we see that this service is back up again. So this is the amazing part of Docker Swarm. If suppose the service goes down, Docker Swarm will try its best to basically relaunch that service. And if it's not able to do it, that's also fine, because I want to show you guys one more thing. Now I have these containers running on each of these nodes, right? If I take an IP address of any of these nodes, if I take the IP of worker1 node, copy it. We didn't copy the node IP. And if we paste it in a browser, it will show it works. So whenever you launch an Apache server, to check if it's working or not, you go to the domain name, and you can see that it works on the worker node 1. So let's see if that happens for Docker manager node 2, manager node. Now we're using the manager also to run the task. Normally you wouldn't do that. And you can see it's working over here. And if we use Docker worker node 2, let me go ahead and copy the IP address over here and then paste it here. And we can see it's working over here also. So you can see that all these services are running on all of these nodes. Now, if I wanted to remove this again, let me just do that command. And let me click the worker node 2. All right, so by the time I even check it, it's already back up. So you can see how fast it is in doing what its job is. So this is an amazing thing about the Docker Swarm. Basically you have replicas of each service you're running, and whenever they go down, the Swarm tries to bring it back up. And there are replicas over here because we want to make sure that at least one of them is up. If two cannot come up because of its regular crashing, at least 1 and 3 are there for the same feature. All right. So this is the Docker service command again to check where your services are running, on which node they're running. All right, so what happens when we remove one of the workers? So let me go ahead and remove this worker. So if I do a Docker swarm leave, now what will happen? So if I do a Docker PS on this again, I can see that there are no more services running here because we removed it from the swarm. Now the services will only run on the swarm if you launched it from the manager node. And if I do a Docker PS over here again, I can see there are two services now. Why did this happen? So this is basically your load balancing. So not exactly, but this is your load balancing where you are shifting the services according to the resources you have. If the swarm only has resources of 2 nodes, then he's going to divide these services onto both of those 2 nodes. If it has 3 nodes, it will divide it equally among those 3 nodes. But if it does not have those 3 nodes, so it's going to basically, divided among the 2 nodes it has. All right. So that's your load balancing. So we can go ahead and remove the service itself. So if you want to remove the service completely, then you can go ahead and type in Docker remove service and the name of the service. And we have removed that service. If you do a Docker PS, if you do it again, we can see that none of the containers are running anymore, even over here. All right, so these are basically how you would launch a service on a Docker Swarm cluster and how you would perform various actions on that server. Now, let me quickly go ahead and launch a service again because I want to show you guys a few more things about it. Docker service create. We'll give this a different name. I'm going to call this demo, and I'm going to create 6 replicas for this to show you guys how the load balancing works again. And we will again use the HTTP image. I want to publish this on the 80 port, basically the default port, HTTPD, and press enter. You're launching 6 replicas, and I'll show you how the load balancing will happen. I'm telling you guys an assumption that basically there'll be 2 services on each node. So if we do a docker ps over here, yeah, 3 services. Okay, yeah, 3 services because we remove one of the nodes, right? So if you do a docker node ls, we can see that one of them is down. So if you want to basically make it join up again, it was this one. All right. Not this one, sorry, this is a manager node. All right, so it joined up again, but it joined as a separate ID. All right, so since you already launched the service, it's not going to do that. I want to show you guys about the Docker service info command. So this command will basically give you the information on your service. Right, so I forgot to write inspect over here. Docker service inspect, and you can see all the details over here, the demo, how many replicated, how many replicas there are, the ID, and whether container specifications, etc. So if you want to inspect your container, this is how you would go ahead and use it. All right. All right, so okay, fine. So we've used the service command. Now I want to show you guys how to make use of Docker stack. Now Docker stack is another thing that you guys might be using. So let me go ahead and remove the service rm demo. All right, so to use the Docker stack, we have to first create a YAML file. So let me go ahead and write this as a project. Oh no, demo.yaml. And open this file. I have already a set of configurations. Okay, so what I want here is I want 2 services to be launched. I want web service and I want database service. Okay, and I'll be using engine X as the image over here, and for the database I'm going to be using MySQL. Let me go ahead and save this. So Docker Stack is basically used in those scenarios where you want to launch a whole software together, where you don't want to launch the services one by one. So you write down all of your services. Now, if you have 5 services, you write them down in a .yaml file. And once you do write them down in your .yaml file, you can go ahead and launch those services using Docker Stack on the Docker Swarm. So right now on our nodes, we have 3 nodes. Let's remove this so we don't have any confusion. Docker node rm removed. All right, we have removed them. So let's go ahead and launch our Docker, this YAML file. Let me just change one thing in that Docker demo.yaml file. We will change the publishing port from 5000 to 8000. And we will change this HTTPD, this engine XMH to HTTPD. All right. All right. So we will go ahead and use the command docker stack deploy -c, and we're going to type in the name of the YAML file, docker demo.yaml, and I'm going to give the name of the stack over here. So I'm going to give this demo stack. All right, so it's creating the network demo stack default. This is a default network it creates, and it's creating those 2 services. I'm sorry for the delay. I'll just wait for you. If you guys can hear me, please go ahead and give me a confirmation. I'm sorry, my internet went down, so I had to switch to a backup internet. I hope you guys can hear me now. Let me just check. All right, so I'm back online. So let me just go back, and I've already crossed a lot of time. So let me just give you guys the basics again. I'll just show you how to use the Docker stack again. So right, so we already used Docker stack. Now we're gonna go ahead and deploy. We already deployed. So basically, we had two services. We had our HTTPD service, that is the Apache web server, and we launched a database, right? So we have two services launched on our Docker swarm. So let's go ahead and see those two services. So we will use the command docker service ls. I'm sorry for the internet speed, guys. My backup internet is horribly slow. So we can see that the database has no replicas, so that means it's not running, but our HTTP, Apache server is running. So there's an issue with this that we can, rectify later. But for now, understand that with your both database and your web, and a replica for each of them is created. So if you wanted more replicas, you can go ahead and change the settings inside of your Docker, YAML file, add a replica keyword and how many replicas you want for each of these services. And automatically, when you launch it using the Docker stack deploy command, you will have those many services launched. Right? So if you wanted to do it separately, right? If you already launched this and if you wanted to scale your service, if I wanted to scale my web service to have like 4 replicas, I want more replicas over here. So I'm going to use a specific command for that. You can use a command called docker service scale, and you can use the service ID or use paste the name. All right, and how many replicas you want. So I want 4 replicas, so I'm going to press enter. Right, so actually not the name, we have to take the service ID. Yeah, okay, so docker service scale, and and the ID of the service you want to scale. All right, and how many replicas you want? 4. My net is way too slow for this. Press enter. Ho ho, it mixed up scale and ID. Mm-hmm. Why is it not working? Right, I forgot to include the equal to symbol. All right, guys, this is what I'll do. My internet is very slow for using this instance. So, guys, go ahead and give me your questions. We're already way too late. So, go ahead and give me your questions. I'll start answering those questions while this is loading. I don't know when this will load. I mean, it's taking way too long. So, okay, yeah, it's loaded now. So you can see that there are 4 services running. Please still go ahead and ask your questions. I want to answer them. And then we'll wrap up this session. I'll do a much better session this session. We have a repetition of it again, so you guys can properly see all of this. All right, so we have our replication happening. So let me just go ahead and use Docker service PS. Let me copy the name of the service. Demo stack web. All right, so Ravi Shankar, you have a question. What is the difference between Docker Compose and Docker Stack? All right, so Docker Compose is basically used to create those multiple containers. Like you saw me write that .yaml file, right? So when I wrote that .yaml file, normally if you wanted to launch multiple containers at the same time and other services, right? So I mean, also services, then you would go ahead and make use of a Docker Compose .yaml file. And then you will build up that service. So it is very similar to the whole, Docker swarm. But Docker Compose is for creating multiple containers at the same time. All right. So difference between Docker Swarm and Kubernetes. All right. So Docker Swarm and Kubernetes. All right. So Docker Swarm and Kubernetes has a lot of differences. They're both orchestration tools, but with Kubernetes, it's a much more, you know, defined tool. It's much more utilized in the whole industry. You won't see people using Docker Swarm. Docker Swarm isn't as robust as Kubernetes, but that is not to say that Docker Swarm isn't good. Docker Swarm has its own specific scenarios where requirements where you use Docker Swarm, but not a lot of companies actually make use of it because Kubernetes has way many more features where it makes use of a much more complicated system where it uses pods to handle different containers. You have one pod in which you have multiple containers, storing the replicas of each service that you're running. So if one pod goes down, you have other pods also, and if one specific server goes down, you have more to replace it. So it uses a much more complicated management system over there. So people usually prefer it. So if people don't use Kubernetes, they make use of any cloud services that provide the same features, like your ECS or EKS. So that's the basic difference. To go more into detail, we'll take another whole video. Or you know what? I'll make a whole video just for Docker Swarm versus Kubernetes so you guys get a better idea of it. Can we have a Docker Swarm setup with worker nodes spread across different physical locations? Yes. So Anuj, that's exactly what I did over here. I have so these services that I launched, right? I launched them on different servers. I didn't launch them on my own system. I used the AWS server, I mean AWS, to launch these instances. Now I don't know where the physical locations of these are, but I can say, I mean, by common sense, that they're not the same service. They're not the same place. You can obviously do that. If you have your servers set up in like Mumbai, in Delhi, in London, and in New York, and you can launch your service, Docker Swarm on all of them. You know, given on the condition that they can talk to each other, that there is no network layer blocking them. Can we use Docker Swarm or Kubernetes in Windows environment? If yes, what are the minimum requirements? So you can use Docker Swarm on Windows. So I will create a whole video for Docker on Windows. Let me go into more detail. I'll create like a 2-hour video so you'll understand how to use Docker Swarm. Minimum requirement, I mean, I am not sure on the specifications, but for Kubernetes, you need a little bit more power. So make sure that you have at least 8 GBs of RAM, Neville, and that should be good enough. Yeah, so if they do have the same private network, then they definitely can be launched on, multiple different locations. So if suppose I didn't make them anywhere, I connected them using my virtual private cloud, and they could talk over the virtual private cloud, then I could definitely launch my Docker service on that. Now, Docker Swarm, it's not necessary that you have to use Docker Swarm. There are other orchestration tools also. Like AWS itself has like multiple orchestration tools. You have like ECS, that's Elastic Container Service. or you can make of EKS, that is Elastic Kubernetes Service. So it has its own management. If you don't want to manage the physical hardware, you can just make use of AWS's own services that they provide you. Is it necessary to learn Linux command, Abbas? I mean, yeah. I mean, I'll be honest over here. Basics are good enough for starting, but if you're going into a deeper end job where making use of Docker a lot, people expect you to know Linux a little better because you will be working with Linux servers. But if it's the case where you're not working with the Linux environment and you're working with the Windows environment, then you need to know about how Windows works. So it's based on your requirements. But yeah, I mean, you need to know at least the basics. I would recommend that, but it's not necessary. But to learn, just know some of the basics, right? So it's easy for you to navigate. So any more questions, guys? All right, so I don't see any more questions coming in right now. So let me finish explaining this and then I can session. So you can see I used the command docker service ps demo stack, right? So what this did was basically it told me what all the processes or where are the replicas of my demo stack service running. So you can see they are divided across. So I did 4 replicas and it created 3 extra replicas for me. And you can see they are launched on different nodes. So 2 are launched on 188. So this is this node itself, manager node, docker ps. If I do, I have 2 nodes over here, 2 services. If I do a docker ps, okay, these ones are inactive. Let me restart. All right, it's gonna take way too long. So you guys can see it from here itself. They're running on different nodes. All right, so this is your Docker service that you have deployed using your Docker stack command. All right, Docker stack deploy, and we learned about the Docker service scale command also. There are more rolling updates where you roll new updates. Like if you want to update your servers to newer versions. So suppose I had a specific version of HTTPD and I wanted to use another version of it, then I will go ahead and use the command docker service update the image I'm using. I suppose I wanted the latest version of HTTPD. If it's not the latest, I will go ahead and use latest, and the one that I want to replace, that is HTTPD I'm using right now. Okay, so this is how you would go ahead and perform any updates. All right, so there were a few more things I wanted to talk about, but we don't have enough time. So guys, I'll talk about that in a repeat session. So say subscribe and look forward to any of the other sessions I have for you guys. All right, so this is Ramindra signing off. Thank you so much for watching, guys.